So we're going to spend a little bit of time today talking about one-sided limits. And so we've seen some of this notation earlier in pre-calculus, but I wanted to review it. I have a problem here, and if you would like to copy down the notes, feel free to hit pause at any time and copy down what I'm doing. And so it looks like kind of I have the same three problems written out, but they're a little bit different. So this is the limit as x approaches 1, but then there's this little plus sign. That little plus sign, notice it's not before, so it's not referring to a plus 1. It just means from the right side, okay? So this means from the right. Then, so I'm only looking at it as I'm coming from the graph from the right side. This means from the left. And then this is just the same thing we've seen before. So when I'm looking at a table, from the right means from the right of the one. So as I'm coming this way, so really we've been doing it's just a notation thing. And from the left means coming in from that way. So what I would like to do is pull this up and take a look. So you can see I have the absolute value of x minus 1 over x minus 1. What you're going to notice is I get these kind of stacked lines. I made a window of -5 to 5. And the reason why that happens is when these look the same, so when it's positive, you take this divided by this, they're exactly the same. You get the number 1. But when you're coming from the left side, when you remove an absolute value, it could also make this negative parentheses x minus 1. So it could also divide and give you a -1. So let's just sketch a picture of that graph so you can see what we're dealing with here. It doesn't have to be perfect. Your calculator doesn't show this, but it actually is not defined at 1. And so we have one piece going this way and then another piece going this way. And there's a gap in the middle. So one thing we can do to do a one-sided limit from the right is we can go ahead and look at the graph, and we can clearly see, this is my fault. I apologize, guys. This should be, I'm crossing that out. This should be at x equals 1, and I made it at 0. So let me just redo that a second. I'll do a little one up here so you can see it. The graph that we were looking at was x equals 1, which is right here. So it actually looked like that. Apologize for my mistake. All right, so we can just put our finger on the graph and see what happens as we come in from the right. And so from the right, these values are clearly up here. So they're approaching 1. What we also can do is on a table, we can set up the table function in our calculator. And that's what I'm going to do next. And see what those table of values are. So we hopefully still have our calculator set up from before. I'm going to go ahead and put a 1 in the middle, and I'm going to put my values to the right, which would be 1.001 and 1.01 and 1.1. Okay, and we can see that these are all 1s. So you can even fill that in with the table if you want. Sorry, my cell phone, I'm gonna have to hold and do this because it's not working for me. Okay, so those were all 1s. Looking at my table again. Going on the other side, I would have to make this not 1.999, we're coming from the left, 0.999. 0.99, 0.9. And you can clearly see that also matches what we see on the graph, that coming from the left, they're -1. So I can fill in my table that way. So you could use a table or a graph, and you can always find a one-sided limit. Sometimes they're going to match. So sometimes over here and here, you get the same value. In this case, they don't. So I'm going to explain what that means. So our limit from the right was clearly, it was 1. So I'm going to write equals 1 there. Our limit from the left was a -1. Now, you can always find a one-sided limit of something because you're going to always be able to find the value it approaches from one side. But remember, the definition of a limit at a point is if it approaches the same value from both sides. Okay, well, this is a really great way to check. Does it approach the same value from the left and from the right? And the answer to that is no, because from the right, the function approaches 1, and from the left, it approaches -1. What does that mean? That means the limit doesn't exist from both sides. So this statement means from both sides. I also wanted to take a look at a piecewise function just in case you wanted to, or you're seeing some values with a graph. So on this one, I have kind of two pieces of the graph. I have a hole over here, and I want to fill in some limits. So I first wanted to look at -1. So here's -1 from the right. So if you're asked to do that today, this statement, -1 from the right, means we're going to be coming in from the right side. And coming in from the right side, the limit, remember the limit's the y value, is a 1. So I'm going to go ahead and put a 1 there. Let's now look at the limit as x approaches 1 from the left. Okay, so from the left means here's -1. Come from the left. We can see it's still approaching that y value of 1. So here's a case, not like the one above, that from the right and from the left, they do approach the same value. So if they do approach the same value, we can also state that is the limit as x approaches -1. So it was 1. On a graph, I wanted to show you one where you can find the left hand and the right hand limit, but you cannot find the limit. So I would like you to take a look at the graph around x equals 2. So let's find the limit as x approaches 2 from the right. I'm going to come on at that 2 from the right. So here's 2. From the right means coming in at this way. So it looks like the function, if I came from the right-hand side, is approaching -1. All right, let's do the left-hand limit. What is the limit as x approaches 2 from the left? So as x approaches 2 from the left, it's not down here, it's actually up here. So I'm coming in from the left, and it's, even though it hops down here at 2 from the left-hand side, until that point, it is up here. And so we'd have to write this is the limit. Remember, a limit is not what it equals, it is what it approaches, what the function approaches. So it looks like the function is approaching a y value of 3. Okay, unlike the last one, remember the last one, the left and the right were approaching the same thing. This one, the left and the right are approaching different things. And what that means is if I asked you to find the limit as x approaches 2, that statement implies from both sides, since they do not approach the same value, we would once again write this doesn't exist. So hopefully this gives you a good idea of how you evaluate one-sided limits, and especially how you find one-sided limits to help you evaluate the limit at a point.